With a population of 30 million, Peru is a country with a rapid growing economy. Nevertheless, 10% of Peruvians have no access to electricity.
Soy Sebastián y tengo 9 años. Estudio en el colegio Nuestra Señora de Rosario y vivo en Santa Rosa de Villa. En mi colegio nos dejan libros para leer, pero no puedo leer porque en mi casa no hay luz. Y siempre tengo que estar en el parque antes que anochezca para leerlo bien.
The idea really came to me when I was watching a documentary about the Amazonian forest and how families there had no lighting. And I thought that this related to our country in Peru, where many families don't have lighting and electricity is really an issue and there's a lack of infrastructure. Therefore, I thought that igem could use genetic engineering to solve this issue.
So, our part within the igem project, FOS, for building our 3D lamp, a bioluminescent lamp, was to find which Lux genes, Lux A through G, we needed and decide in what order they'd be added. So we decided to use the Lux gene as it's probably the most efficient when placed in E. coli for bioluminescence. And I just want to explain a little bit as to what the Luxes are. So first we have Lux A and B. These are responsible for the synthesis and creation of alpha and beta subunits. We have Lux C, which is in charge of creating AMP. We have Lux D, which is in charge of directing fatty acids to the actual chemical equation. And finally, we have Lux E, which is responsible for making the cycle go over again. So that's just really a basic explanation without really delving deep into what they actually do. And really, we decided upon a multitude of different combinations of the Lux A through G, and we wanted to see which of them would be the most efficient, and we did a lot of research into this. We looked at different types of Luxes, we looked through past igem projects, and based off of our research, we gathered different Luxes from other projects, from other research, and I think we have a pretty good combination. Unfortunately, our parts were not able to come in time, so we weren't actually able to test this ourselves. But from our research, we believe that our Luxes would have worked well and that we would have had good results.
The human practices part of our project is basically focused on teaching others and raising awareness and knowledge, not only about our project and the problems it focuses on, but also on science in general. Since us being in Lima, Peru, in our city, there isn't much contact with science and the public. So we're trying to optimize that through teaching in many communities. First of all, in our school, which is our closest community. Also in the general public through handing out surveys on synthetic biology.
So the igem team at FDR is currently working on making a 3D printed prototype to actually put the bacteria in for the book light to actually work. We're using the software called Tinkercad, which at first was very hard to maneuver around, but after a while we got used to it. I guess a struggle that we had so far is we didn't exactly know how many holes to put the light in that we should put in the prototype for the book light, because we didn't exactly know how bright the light would be. So we kind of guesstimated and took our best guess and just played it safe and went for 4 holes.
Even though we did not complete the second or the third part of our process, which was the Cambridge construct and our own blocks operon, we plan to, in the future, with more work and more time, that we will be able to accomplish this task and solve the lighting issue once and for all with biotechnology.